Layer 2 switching. Virtual local area networks. Configure VLANs to logically divide a layer 2 network into multiple broadcast domains. Describe VLANs and VLAN tagging. VLAN split your physical LAN into multiple logical LANs. In NAT operation mode, each VLAN forms a separate broadcast domain. Multiple VLANs can coexist in the same physical interface, provided they have different VLAN IDs. In this way, a physical interface is split into two or more logical interfaces. A tag is added to each Ethernet frame to identify the VLAN to which it belongs. VLAN tags and frames. This slide shows an Ethernet frame. The frame contains the destination and source MAC addresses, the type, the data payload, and the CRC code to confirm that it is not corrupted. In the case of Ethernet frames with VLAN tagging, according to the 802.1q standard, 4 more bytes are inserted after the MAC addresses. They contain an ID number that identifies the VLAN. An OSI layer 2 device such as a switch can add or remove these tags from Ethernet frames, but it cannot change them. A layer 3 device such as a router or a FortiGate can change the VLAN tag before proceeding to route the packet. In this way, they can route traffic between VLANs. How FortiGate uses VLAN tags? When operating in NAT mode, FortiGate operates as an OSI layer 3 router in its most basic configuration. In this mode, VLAN is an interface on the device. VLAN tags may be added on egress, removed on ingress, or rewritten based on a routing decision. FortiGate does not add VLAN tags on ingress. This is the responsibility of the previous device. How FortiGate uses VLAN tags? When operating in NAT mode, FortiGate operates as an OSI layer 3 router in its most basic configuration. In this mode, VLAN is an interface on the device. VLAN tags may be added on egress, removed on ingress, or rewritten based on a routing decision. FortiGate does not add VLAN tags on ingress. In this example shown on this slide of NAT operation mode, a host on VLAN 100 sends a frame to host on VLAN 300. Switch A receives the frame on the untagged VLAN 100 interface. After that, it adds the VLAN 100 tag on tagged trunk link between switch A and the FortiGate. FortiGate receives the frame on the VLAN 100 interface. Then it routes the traffic from VLAN 100 to VLAN 300, rewriting the VLAN ID to VLAN 300 in the process. Switch B receives the frame on the VLAN trunk interface and removes the VLAN tag before forwarding the frame to its destination on the untagged VLAN 300 interface. Creating VLANs. To create a VLAN using graphical user interface, click Create New, then select interface, then in Type, drop-down list, select VLAN. You must specify the VLAN ID and the physical interface to which VLAN will be bound. Frames that belong to interfaces of that type are always tagged. On the other hand, frames sent or received by the physical interface segment are never tagged. They belong to what is called the native VLAN. Note that a multi-VDOM environment, the physical interface and its VLAN sub-interface can be in separate VDOMs. In what mode does FortiGate needs to be to route traffic between VLANs? NAT mode. Then we move on to the transparent mode. Configure FortiGate interfaces to operate as a layer 2 switch. Configure a virtual domain to operate in transparent mode. Operations mode. Traditional IPv4 firewalls and NAT mode FortiGate devices handle traffic the same way that routers do. Each interface must be in different subnets, and each subnet forms a different broadcast domain. FortiGate routes IP packets based on the IP header information, overwriting the source MAC address. So if a client sends a packet to a server connected to a different FortiGate interface, the packet will arrive at the server with a FortiGate MAC address instead of client's MAC address. In transparent operation mode, FortiGate forward frames without changing the MAC addresses. When the client receives a packet from the server connected to a different FortiGate interface, the frame contains the server's real MAC address. FortiGate doesn't rewrite the MAC header. FortiGate is a layer 2 bridge or switch, so the interfaces do not have IP addresses, and by default all belong to the same broadcast domain. This means that you can install a transparent mode FortiGate in a customer network without having to change the customer's IP address plan. Some customers, especially large organizations, don't want to reconfigure thousands of devices to define a new internal network that's separate from their external network. Hello, it's mic testing. This slide shows an example of NOT operation mode. FortiGate has 3 connected ports. each with separate IP subnets. All interfaces on FortiGate have IP addresses, and in this case, NAT translates between networks. Firewall policies allow traffic to flow between networks. FortiGate handles packets according to their routes. In most cases, routes are based on the destination IP address. Clients on each subnet send frames that are destined for a FortiGate MAC address, not the real MAC address of the server. This slide shows an example of transparent operation mode. Firewall policies can then allow or block traffic, but there are differences. Notice that the physical interfaces on FortiGate have no IP addresses. Therefore, FortiGate won't respond to ARP requests. However, there are some exceptions. For example, when changing to transparent operation mode, you must specify a management IP address in order to receive connections from your network administrators and send log messages, SNMP traps, alert email, and so on. This IP address is not assigned to a specific interface. It is assigned to the VLAN settings. The management IP address has no effect on traffic passing through FortiGate. By default, a transparent mode FortiGate won't perform NAT. Also, clients will send frames destined directly to the real router or server MAC address. FortiGate as a transparent bridge. A transparent mode FortiGate acts as a transparent bridge. What does that mean? It means that FortiGate has a MAC address table that contains, among other things, the interface that must be used to reach MAC address. FortiGate populates this table with information taken from the source MAC address of each frame. FortiGate as a transparent switch splits the network into multiple collision domains, reducing the traffic in the network and improving response time. Forward domains. By default, in transparent operation mode, each VDOM forms a separate forward domain. However, interfaces do not. How does this affect the network? Until you change the initial VDOM configuration, all interfaces, regardless of their VLAN ID, are part of the same broadcast domain. FortiGate will broadcast from every interface in the VDOM in order to find any unknown destination MAC address. On large networks, this could generate massive broadcast traffic and overwhelming replies a broadcast storm. FortiGate with one forward domain. This slide illustrates the problem a broadcast with all the interfaces on the for domain 0. One device sends an ARP request, that is address resolution protocol request. It reaches FortiGate through one of the interfaces in the VDOM. Because all interfaces belongs to the same forward domain, FortiGate rebroadcasts to all other interfaces, even to interfaces that belongs to different VLANs. This generates unnecessary traffic. After that, the ARP reply will still arrive on only one interface. FortiGate will learn that the MAC is on that interface. FortiGate with multiple forward domains. As you learned earlier in this lesson, forward domains are like broadcast domains. The example on this slide shows the same network as before, but different forward domains ID are assigned to each VLAN. Traffic arriving on one interfaces is broadcast to only to interfaces that are in the same forward domain ID. Transparent mode MAC table. This debug command lists the MAC address table in a VDOM operating in transparent mode. The table shown on this slide contains the outbound interfaces to reach each learned MAC address. Which of the following statements about FortiGate operating in transparent mode is true? It has management IP address. How can an administrator configure FortiGate to have 4 interfaces in the same broadcast domain? Configure the operation mode as transparent and use the same forward domain ID. Virtual wire pairing. Segment the layer 2 network into multiple broadcast domains. Virtual wire pair. You can use virtually wire pairing when only 2 physical interfaces need to be connected to the same broadcast domain. The most frequently seen example of this is FortiGate connected between the internal network and the ISP's router. When you configure virtual wire pairing, 2 ports are logically bound or linked, acting like a filtered cable or pipe. All the traffic that arrived at one port is forwarded to the other port. This prevents issues related to the broadcast storms or MAC address flapping. You can create more than one virtual wire pair on FortiGate. Virtual wire pairing and transparent mode. This slide shows an example of 2 virtual wire pairs used on FortiGate in transparent mode. This FortiGate has 4 ports, each connected to different physical locations, but traffic is not allowed to flow between all 4 locations. Virtual wire pairing allows traffic only between ports in the same pair, between port 1 and port 2, and between port 3 and WAN 1. So in this example, the network on port 3 can reach the internet through WAN 1. However, the networks on port 2 and port 1 can't reach the internet. They can only reach each other. Virtual wire pairing in NAT mode. This slide shows an example of a virtual wire pair on FortiGate operating in NAT mode. In this example, IP packets ingressing interfaces WAN 1 and internal are routed using the IP header information. Those 2 interfaces have different IP addresses and each one forms a separate broadcast domain. The cases of interfaces WAN 2 and DMZ are different. Because these interfaces are configured as a virtual port pair, they don't have assigned IP addresses. They form one single broadcast domain. Observe the IP addresses for the server and the router connected to WAN 2. They must both belong to the same subnet. So virtual wire pairing offers a way to mix NAT mode functionalities with some transparent mode functionalities in the same VDOM. This scenario is most commonly used as a segmentation firewall. This configuration allows for integrating FortiGate into an existing network where the web server is on a public IP address. It prevents the need to use the virtual IP and provides isolation from the rest of network. It also allows immediate integration of FortiGate into an established network and provides a migration path to the FortiGate infrastructure. Virtual wire pair configuration. When you create a virtual wire pair, you must select 2 physical interfaces, no more and no less. After selecting the 2 interfaces, you create the virtual wire pair policies that inspect the traffic crossing the virtual wire pair. The wildcard VLAN settings specify how those policies are applied to the different VLANs whose traffic flows between the pair. If wildcard VLAN is enabled, the virtual wire pair policies are applied equally to the physical interfaces and VLANs. If wildcard VLAN is disabled, the virtual wire pair policies are applied only to the physical interfaces. Traffic with any VLAN tag is denied. Virtual wire pair policies. The firewall policies for virtual wire pairing are configured under a different menu item. This menu item is displayed when you have created at least one virtual wire pair. You can create bidirectional firewall policies which allow traffic to be initiated from either direction, or you can create separate firewall policies for traffic flow in each directions on the virtual wire pair. You need to enable policy advanced option under feature visibility to see the firewall virtual wire pair policy menu. What configuration setting must be enabled to allow VLAN tag traffic through a virtual wire pair, wildcard VLAN? How is traffic handled in a virtual wire pair? Incoming traffic to one interface is always forwarded out through the other interface. We will see software switch. In this, we will learn how to configure a software switch. A software switch groups multiple interfaces to form a virtual switch, which acts as a traditional layer 2 switch. This means that all switch interfaces are part of the same broadcast domain. Software switch configuration. Each software switch has a virtual interface associated with it. Its address is shared by all physical switch interfaces and member SSIDs. You use this virtual interface in the firewall policies and routing configuration. Software switch example. In this example, the administrator grouped the wireless interface with port 1 and port 2 to form a software switch. These three interfaces are part of the same broadcast domain. All the devices connected to the switch interfaces belongs to the same IP subnet 192.168.1.0/24. This allows FortiGate to forward broadcast traffic from the wireless clients to port 1 and port 2. The software switch interface itself has an IP address which is also in the same subnet 192.168.1.0/24. This is the default gateway IP address for all the devices connected to the software switch. The server is connected 10.0.1.1 is connected to an interface DMZ that is not part of the software switch. So it belongs to the different broadcast domain and the IP subnet. In which operating mode is a software switch function supported? NAT mode. Which of the following can be the members of the software switch wireless interface? Next, we will see spanning tree protocol. In this, we learn how to install FortiGate in networks and running spanning tree protocol. Broadcast terms we will see. Whenever possible, network designers try to provide redundancy in their networks. The larger the network, the more critical in need for redundancy. However, redundancy introduces its own issues. When an Ethernet switch receives a frame, it forwards that frame to all ports in the same broadcast domain except the port it received the frame on. If there is a redundant path in the network, the frame will be broadcast over both links. This would create what is called a broadcast storm, which will eventually lead to a complete collapse of the network as the frame gets rebroadcast over and over again across each port. STP enabled. To prevent broadcast storms, you can use spanning tree protocol. Spanning tree protocol works by first selecting one switch in the broadcast domain to serve as the root bridge. The switches then begin exchanging special packets called Bridge Protocol Data Units or BPDUs. These BPDUs provide each switch with information about its neighbors and its neighbors' interfaces. When all the paths are known, the switches identify potential loops and designate a root port based on lowest forwarding cost. That will be the primary path. The other ports which could result in a loop are blocked. Because the BPDUs are sent every 2 seconds, the switches are able to detect any network outages and unblock ports as needed to restore the alternate path around the outage. By default, FortiGate does not participate in STP learning or forward BPDUs, but you can enable it. You must still restrict broadcast domain so that they are not overwhelming large. STP configuration, that is spanning tree protocol configuration. To enable FortiGate to participate in the spanning tree protocol tree using the config system STP command on this command line interface. Note that this is only supported on models that have physical switch interfaces such as FortiGate 30D, 60D, 60E, and 90D. Spanning tree protocol forwarding for interfaces that are not physical switch interfaces. You can either forward or block STP BPDUs. What is the default STP mode for the FortiGate? FortiGate has all STP functions disabled. Best practices. Create forwarding domains when VLANs are used and set VLAN forward to disable on all relevant physical interfaces. The forward domain ID can be different from the VLAN ID, but it is not recommended for troubleshooting and readability to keep the same. When using forwarding domains, a router is required to move traffic between the forwarding domains. Only interfaces from the same forwarding domains can have firewall policies between each other. Because STP BPDUs are not forwarded by default, use caution when inserting the FortiGate, that is, or any other forwarding device, because this could break the spanning tree and lead to layer 2 loops.